So hey guys, welcome to our discussion on limits. In this video, we will be discussing about the existence of limits. So let us say we have a function f of x is equal to greatest integer of x. So let us draw first the graph of this function. So we have this y-axis over here and this is x-axis. This is 1, 2, 3. Similarly, -1, -2, -3, and this is 1, 2, and 3. So let's draw the graph for this function. This is 0. So from values of x from 0 to 1, the value of greatest integer x will be equal to 0. So we will be making it open at x equal to 1. Similarly, from 1 to 2 and similarly from 2 to 3. So this is the graph for greatest integer x. F of x is equal to greatest integer x. Right. So now back from our previous video, we have to compute limit at a certain point. So let us say we will be computing limit at x equal to 1. So our objective is limit x approaches to 1 f of x. This is what we need to calculate for this particular function. So let's now evaluate the value of this function as we are approaching towards 1. So let us first approach from the left side. When values of x are very close to 1 but less than 1. So that will be function, let's say f of 0.99999. So computing from this branch, we will see the value will be 0. So this will be f of 0.9999 will be 0 since we are at this branch, and similarly when we approach this x equal to 1 from the right side. So let us say we compute the value of this function at 1.00001, that is from right side. So at this value of x, the function will be on this branch. So its value will be 1. So from now on, we will be taking this value, that is the value less than that point and very close to that point. We will be taking it as 1 negative and this is 1 positive. So this is the symbolic meaning of values of x less than 1 but very close to 1. So this is value of x greater than 1 but very close to 1. So now we will be writing it as limit x approaches to 1 minus. So as we are approaching from the left side, so this is nothing but the left hand limit. So this will be equal to 0. This we can write as f of 1 negative. So this will be equal to 0. Similarly, we will be covering, or we will be writing that f of 1 positive, that is limit x approaches to 1 positive f of x. So that will be 1. Now we will see that this will be RHL and this is the right hand limit, and so this is the left hand limit. So this so now for this limit x approaches to 1 f of x, if this exists, then this should be equal to this as well as this. So in order for the existence of a limit, it should not be dependent, that if we approach from the left side or from the right side, the result should be the same. So this is the basic condition which I am going to write now, that the LHL should be equal to the RHL. So this is the condition for the existence of limit. This is the condition. Okay. So the limit will exist only if these two limits are equal, and both these also should be a finite quantity. And it is irrespective of the fact that the value of that function is existing at that point or not. So this is a basic condition for the existence of limit. So now let us have some other notation as well. So this was the LHL. LHL is equal to RHL. So LHL is equal to, and this was f of 1 negative in our case was equal to f of 1 positive from LHL equal to RHL, right? And this was limit x approaches to 1 negative was equal to limit x approaches to 1 positive f of x. So now I will introduce a different notation as well for the evaluation of limit. So let's say for this limit, this LHL as x approaches to 1 minus, or we can say 1 negative, in our case we were writing as x equal to 0.9999. So let us say we have x equal to 1 minus h, and this h is a very small quantity, but it is a positive quantity. So since x approaches to 1 negative, then this h will actually approach to 0. This h value will be very close to 0. So we will be writing this left hand limit. Let's introduce h over here in place of x. So that will be limit when x is approaching to x is approaching to 1 negative, this h will approach to 0. So we'll be replacing this thing x approaches to 1 negative with h approaches to 0, and this fx will be nothing but f of 1 minus h, since x equal to 1 minus h. So now this is the left hand limit. So this is another way of writing the left hand limit. Similarly, for the right hand limit, let us say we have x equal to 1 plus h, and same thing here. This h is a very small quantity. So since when x is approaching to 1 positive, this h will approach to 0. And similarly, we can write this right hand limit as limit when, so we'll replace this x approaches to 1 positive with h approaches to 0. And we will write this x as 1 plus h. So this is another way of writing the right hand limit. And this is another way of writing the right hand limit and the left hand limit, right? So but from now on we will be considering this as our notation, this one. So I was just introducing you another way of writing this left hand limit as well as the right hand limit. So we'll be sticking to this notation. This notation will be our consideration. So guys, I hope you might have understood the existence of limit from this video. Do join me for the next set of videos. Thank you guys.